So permutation and combination is one of the chapters which is very scoring, right? And if you are through with the concepts of this, you would be able to solve the probability also very well. Okay, so and this is very interesting. As I always tell you, do not skip the questions from P&C and probability chapter, because those are scoring ones and very much frequently asked during the exams. Okay, so we have already seen one practice session for permutation specifically, and in this lecture we are going to see many examples on combination. Okay, so yes, let's quickly get started with the examples, and the first example is going to be very easy, just as a brush up, right? So it is already flashing on your screen. So yeah, what they are asking, in how many ways 5 students can be chosen from 12 students? Okay, so now as you know, when you have to choose or select something, it is combination. Yes, so what they are asking, in total how many are there? 12 students are there, and how many you have to select? 5 you have to select, correct? So 12 C 5, isn't it easy? N C R, N means total number of items, and R means what? The items which you are selecting, correct? So you have to select 5 students out of 12 students, hence the formula is 12 C R. So that gives you, what's the formula? N factorial divided by R factorial into N minus R factorial. You already know that, right? So this is N factorial, this is R factorial. N minus R means 12 minus 5 is 7 factorial. Yes, the solution part or calculation part is on you. Okay, I am not going to solve this completely, but I'll just give you the hint like how to solve or do such calculations. You literally don't have to do the 12 factorial completely, then 7 complete, 5 complete. No, right? So how you can do this? 12 into 11 into 10 into 9 into 8 into, you can stop at 7 factorial because that is there at the denominator, correct? Then this 5 factorial means whatever 5 into 4 into 3 into 2 into 1. Okay, and then this 7 factorial, that goes. Now simplify the further things. Okay, so that is how you solve the factorial basically, and this is the first very easy example from the combination. Let's go to the next little interesting and little different example. Okay, so there are 10 people at a party who shake hand with each other. If each two of them shake hand with each other, how many handshakes can happen at a party? See, very interesting, very easy, but just looking at the question, you should not get, confused or scared. Okay, now see, there are 10 people. Let's assume that these are 10 people. Okay, and these people are shaking hands with each other in a party, 2 at a time. He does handshake with this, with this, and with this. So the answer in nutshell is going to be very easy. How many total people are there? 10 total people are there. How many are shaking hands, or how many you have to select at a time? 2 are shaking hand, correct? So you have to select 2, and then you do the further step. 10 factorial divided by 2 factorial into 8 factorial. Easy. So that's how you get the solution of second question. Now let's go to the third question. Now quickly check the next question. Okay, how many diagonals are there of a 12-sided polygon? Okay, so see, very interesting, very nice question it is. Okay, just let's take the this example on a small scale to understand this concept, right? So what they have given you, 12-sided polygon, correct? Means that there are 12 such points, right? And it is like 12-sided polygon is there. Okay, something like that. So these are the 12 sides basically, right? But then to understand this 12-sided polygon, let's consider first maybe 5-sided polygon. Okay, so 5-sided polygon is something like, these are 4, right? So it's something like this, 1 2 3 4 and 5 sides are there. This is polygon. Yes, okay. So when you have 5-sided polygons, you automatically will have 5 points to it, right? So if you want to draw the diagonals in this 5-sided polygon, how you would do that? See now, say from this point, how many diagonals are possible? Here and here only, right? Not here and not here, right? Because those are the adjacent sides. Maybe you can try for the other one also. From this point you can draw diagonal here and here, but not here and not here, not to the adjacent sides, correct? Because those are sides, those are not diagonals basically, and only one diagonal is remaining, is this one, right? So basically what I'm trying to tell you here is, when you have to form the diagonals, you don't consider the adjacent sides, okay, or adjacent points, and you will consider all other points for the sake of diagonals. So if you have to solve this, how it would fit in the formula? Say for example, in total there are 5 points, right? You are to form a diagonal, you need 2 points at a time, that is for sure. So you need 2 points at a time. So what this formula gives you the answer as 5 factorial divided by 2 into 3 factorial. So 5 into 4, this 3 factorial goes and divided by 2, 2 2s are 4. So this is 10. But is it diagonals only? No. When you are saying out of 5 you have to consider 2 points at a time, it will consider the adjacent points also. But then you have to subtract those adjacent points or adjacent sides basically, correct? So means in total you are going to subtract all of these 5 sides because sides are not diagonals basically, right? So that is why you will subtract that number of sides from this to get the final answer of the diagonals only. Okay, so 5 diagonals are possible. Is it right? 1, 2, 3, 4 and 5. Yes, the orange colored ones are the only diagonals and others are just the sides, correct? So 5 is the answer. So what is the trick in this question? When you find out by using the formula, you will get all the diagonals plus sides, and then you have to subtract those sides to get only diagonals because those are only asked in the question, correct? So same way, when you have the 12-sided polygon, see this is not really 12-sided, but I just wanted to show you how the 12-sided may look. So 12 points at a time, out of which you are selecting 2 points to form a diagonal. So this is going to give you what? 12 factorial divided by 2 factorial into 10 factorial, which is what? 12 into 11 into that 10 factorial goes and then 2. So 2 6 and this is 66, correct? But then you have to subtract the sides also. So how many sides are there for 12-sided polygon? They are already saying that in the question itself, right? It is 12-sided. So subtract this 12 from the 66 and then you will get 54 as your final answer. So 54 diagonals are possible. Like in this example, 5 diagonals were possible. That is why you were able to do it manually also, right? And that is why I showed it to you on this very small scale to understand the concept, correct? And that gives you like 54 diagonals are possible in this 12-sided polygon. Okay, clear? Okay, so next question is, how many triangles can be formed using 10 points in a plane out of which 4 are collinear? Okay, super interesting question and you will just love the answer to this. Okay, so now see, we'll go step by step. In total there are 10 points out of which 4 are linear, meaning that 6 are non-collinear. What is linear, non-collinear? Linear means in a line, non-linear means not in a line, basically simple. So say for example, these are those 4 points. Okay, I just brought up these points. So these are the 4 points which are linear points, 4 linear points, correct? So these are those 4 linear points, and then you have got 6 non-collinear points. 1 2 3 5 6, done. Okay, so these are those 6 non-collinear points, and they are asking you how many ways triangles can be formed from this. Okay, assume that these are 2 different sets. Okay, so let's understand that to form a triangle you need 3 points, right? So triangle can be this way, this way, this way, anyways, correct? But then the basic concept is you need 3 points to form a triangle. Maybe you can take 1 point from these linear points and 2 points from this non-linear points and you can form a triangle. This way it is possible, right? So you can take 1 point from linear and 2 points from non-linear. Let me write it down. 1 point from linear and 2 points from non-linear, correct? That is going to help you to form a triangle. Second case can be, you can take maybe 2 points from linear and only 1 point from non-linear. This is also valid triangle, correct? So you can take, or the second case is, you can take 2 points from that linear set and 1 point from that non-linear set, right? Or third case, you can take all the 3 points from non-linear set, right? Because those are non-linear, you can definitely form a triangle out of it this way, or maybe this, or maybe some more ways or combinations. So the third case is what? You can take all the 3 points from non-linear set, right? But then, is it possible to take all the 3 points from the linear set? No, right? That is not going to help you to form a triangle. That will give you a line, straight line, because those are linear, right? So you have only these 3 cases. Now, let's convert this into the formula. This is you are selecting 1 point from the linear. How many linears are there? 4 linear points are there. Okay. Okay. And how many non-collinear points are there? You are selecting 2 from non-collinear. How many are there? 6 non-collinear. And you are taking AND of this. And means multiplication, fundamental principle of multiplication. Second case is what? You are selecting 2 from linear out of 4, and you are selecting 1 from non-linear out of 6. Again you are doing AND of this. And in last case, what you are doing? You are selecting all the 3 points from non-linear, means from the set of 6. Okay. And you are doing what? OR of this. OR means addition. Fundamental principle of addition. Okay. So you are not doing all of these cases or all of these activities same time, right? What you are doing? You can do this way or this way or this way. Yes. And that is why there is a plus sign to segregate this OR. Okay. And when you solve this completely, you will get the final answer. Now you have to tell me what is the final answer for this question. But isn't it interesting? Yes, I like such logical questions actually, right? Which are there to help you, in your practical or in your day-to-day life also. You can have many such situations in your day-to-day life also, right? So I will just give you the hint of the final answer. Final answer is 116. Now you have to tell me if this is right or wrong. I mean, I try to bluff with them many times, giving you the wrong answer, and you have to correct me in the comment section saying that no ma'am, you put it wrong, but then I purposely put it wrong so that you correct me there. Okay, which gives me the proof that you have solved it. Okay, so that's the whole purpose of this. Okay, a team of 4 has to be selected from 6 boys and 4 girls. Okay, so 6 boys are there and 4 girls are there. Okay, and you need to form a team of 4 people. Okay, what is the condition next? How many different ways a team can be selected if at least 1 boy must be there in a team? Quite easy, right? So again there are going to be different cases in this. First case is what? At least 1 boy has to be there, right? So maybe you can have 1 boy and 3 girls. Possible, yes. Maybe, or you can have 2 boys, because at least 1 boy means more than 1 boy is also a valid condition. So 2 boys and 2 girls, because you need a team of 4, right? So this should always make a total of 4. There is no any constraint or restriction on girls, correct? Or maybe you can have 3 boys and just 1 girl, correct? Or last condition, maybe you can have all the 4 boys. Yeah, but then why should boys have all the fun? Just kidding, here boys can have all the fun. Okay, now you have to solve this or convert this into the formula same as the previous example and then solve it further. So let's convert it into the formula and I'll stop at that step only. Okay, so when you convert it, so 1 boy you are selecting out of 6 boys and 3 girls you are selecting out of 4 girls. Okay, this is one possibility. Or you can do it like 2 boys are selected from 6 boys and 2 girls are selected from 4 girls. Or next is what? 3 boys are selected from 6 boys and 1 girl is selected from 4 girls. Or 4 boys are selected from 6 boys. So this is how the expression is formed, and the solution part or calculation part is obviously on you. Now I am not even going to give you hint for this. You have to completely solve this and tell me the answer for this. Okay. Okay, so the next question is, yeah, see now, this happens practically also, right? When you face some competitive exam or even in the any exam, you might have the scenario, such kind of scenario. Okay, so it is compulsory to answer 10 questions in an examination, choosing at least 4 questions from each part. Part A and part B are there. Okay, if there are 6 questions in part A and 7 questions in part B. Okay, so see, there are 2 parts in the exam, part A and part B. How many questions are there in each part? So part A has 6 questions in total and part B has 7 questions in total. Okay, and it is compulsory to answer how many in total? 10 questions you need to answer. Okay, choosing at least 4 questions from each set. Minimum 4 from A and minimum 4 from B should be covered. And just 4. Say if I attempt 4 from this, 4 from this, is it valid or are you going to pass? No, because the total should make it as 10 here. Okay, and they are asking also specifically in the question that in how many ways can 10 questions be attempted. They are not saying that minimum 10 can be attempted. They are saying exactly 10 should be attempted. Okay, so that makes our question or our answer little bit easier. Okay, because they are saying that okay, you need to attempt exactly 10 questions out of these 6 plus 7 and minimum 4 from each section. Okay, so now what can be the cases? Again, let's discuss the cases. So you can attempt 4 questions from first set and you can attempt remaining 6, right? It should make a total of basically 10. 6 questions from set B. This is one possibility. Or maybe you can attempt 5 questions from set A and remaining 5 questions from set B. Still good, right? Minimum 4 from each section. Or maybe you can attempt 6 questions from set A, means all the 6 questions from set A, and 4 questions from set B. Still it is valid. Yes? Is there any other possibility to fulfill all the conditions, this minimum criteria also and this exact 10 criteria also? No, I don't see any other combination or any other case basically. So these are the 3 cases we see here. The important part, students, to solve these combination examples is this only, right? You think about it logically, you find it out the logical statement for it, and then you convert it into the formula. Converting this to the formula is very easy, but then this statement formulation has to be done in a right way, right? If this goes wrong, everything is going to be wrong. Now you know the further step. I'm not going to do even the expression part here for you completely. I'll just show you. Okay, so now what they're saying, you are selecting 4 questions from set A. How many are there in set A? 6 total. And you are selecting 6 questions from set B out of 7. So this is one condition. Okay, maybe I can do the equation part. That much I can do for you. Or means plus sign. What's the second condition? You can select 5 questions from set A out of 6. Right? Out of this 6. And you can select 5 questions out of 7 from set B. Valid again. Or you can select 6 questions out of 6. All the 6 you can solve from set A. And you can solve just 4 questions from set B out of 7. Right? Easy. Very easy. Now do the solution part. This is for practice purpose, right? Why I'm not giving you solution? It's not really a big task, but then that is for the practice purpose. And you have to do it, correct? You don't have to really literally completely solve this. You have to just cancel the things and simplify the expression, and then you will get the answer. Okay, cool. Now let's move to the next question. So what are they saying? A cricket team of 11 players is to be formed from 16 players. So total there are 16 players, out of which they have given the segregation, right? Including 4 bowlers and 2 wicket keepers. So 4 bowlers are there, 2 wicket keepers are there, and remaining, how many are remaining? So 10 are remaining. 10 you can call them as others. Okay. So 10 are others. Okay. And you have to form what? Team of how many? 11 players. Okay. Is there any condition further? You need to select at least 3 bowlers and 1 wicket keeper. Yes. And in how many ways this can be formed? The team of 11 can be formed. See, now I'll just give you the cases and you have to do the further part. Okay. So first case can be what? First case can be you select 3 bowlers and you select 1 wicket keeper and whatever is remaining others, okay, to form the team of 11, right? So what's that? 7, no? 7 others. 7 plus 8 plus 3 is 11, right? The other possibility is going to be what? Or. Next possibility is what? You still select the 3 bowlers only, but then along instead of 1 wicket keeper, you select 2 wicket keepers and then 6 others, okay? Or what can be the next case? You can select, instead of 3, you can select 4 bowlers and 1 wicket keeper, and so this is 5, right? 6 others. Or you can take the last combination as 4 bowlers and 2 wicket keepers and 6 and 5 others. Yes. So these are the only 4 possibilities are there which fulfill all the criteria, right? You need to form the team of 11. So total of this should be 11 in all the cases. Then minimum 3 bowlers and 1 wicket keeper. So yes, that is also fulfilled here. Okay. Now the expression, now the solution part is on you. Solve this and let me know the answer of this. So I hope this video helped you. You know, there is nothing to mug up in mathematics. Okay, everything is logical. So basically you have to understand that logic and concept. And yes, keep practicing, keep studying, and see you in the next video. Bye bye.